So we're going to pick up where we left off last time. If you recall earlier, we had talked about the QuoteServices app case study. I'd given an overview of the various components that made up the system. We talked a bit more about the Eureka discovery service. And now we're going to kind of zoom in on some of the common structure and functionality. In particular, this set of components, the base application, the quote class, and the ArrayUtils class, provide a customizable foundation for other parts of the quote microservices. In particular, this factors out code that's common between the handy application microservice and the zippy application microservice. So we'll start by taking a look at base application. You can get a look at the base application code here at the link at the bottom of the slide. And this is essentially a class that's extended by both the handy application and the zippy application. And it factors out common code that's used in a couple of places. So one thing we do is we define a static run method, which is used to build a Spring Boot microservice that has the class, the class that's provided as a parameter here. And you can see what we do is we go ahead and take that class that's passed in, which would be either handyApplication.class or zippyApplication.class, and we call the getName helper method here, which goes ahead and extracts from the class the name of the package. So for example, we get the package name, which in this case would be something like zippy or handy or so on. And it takes that information and it passes it back. And then that's used to set the name as the property of the app, which can then be used with Eureka in order to register the app with that particular name. Let's talk a bit about the quote class. Quote's a very important class here, and it's used to store quote objects in both the JPA and the R2DBC databases, as we'll see in just a bit when we talk about the Zippy microservice, which uses JPA, and the Handy microservice, which uses R2DBC. We have two different ways of storing these quotes persistently. So quote is a class, as you can see here, and you can get the class at the link below. And we mark the class using the entity annotation. And this essentially indicates that the quote class can be used to create persistent objects that are stored as records in the database, either JPA or R2DBC. So you have to annotate the class to make it something that can be used as an entity to be stored in a database. We also indicate the table name. So the table name indicates which table in the database is going to be associated with instances of this class. And in this case, we're going to call it the quote database, which makes sense because it's the quote class. And this is very similar to the other discussion we had about convention over configuration, which is one of the key patterns in Spring, where if you have a database named quote, you have a table named quote, we have a class named quote, we're trying to keep things consistent. The next thing we do is we go ahead and we define the ID number of the quote. Each quote has a unique ID starting at basically 0. So each quote that we make in the database, that is its so-called primary key, and we use that in order to be able to identify things by the ID. There's also, of course, the quote itself. So the ID is an integer, and you'll notice that we have a couple of annotations for this. The first one, the @ID, is used for JPA. So this is actually coming from the Jakarta Persistence API ID annotation. Then we also provide another ID annotation, which is coming from org Spring Framework data annotation.id. And that's the annotation that's needed for R2DBC. And both of these things are used to specify the ID as the primary key in the database rows. It's a column that identifies the primary key for each row. Now, it can be tricky to design entity classes like quote that work with both JPA and R2DBC. So this is how you can do it. Now, as to whether you would normally do this in most applications, this is a little bit specialized for this particular example because we're trying to have two different databases in the same project. Usually you have one database per project, but we have one project with two databases, so we had to annotate it like this. The other field that we have in the quote entity is the string that contains the zippy quote or the handy quote. That's also, of course, stored in the database as well. we don't have to annotate that with anything. That just ends up being a column in the database. Now, there's a couple other things that we have here. The quote class implements the comparable interface, which enables the quote to be used if you want to sort the quote objects using sorting operations, sorting algorithms. And so we're going to have a compare to method, which is what comes from comparable. And we use that to compare two quote objects to see how they relate to each other for the purposes of sorting. And as you can see, all that's doing is just doing compare to on the quote string to see if they're going to be equal, or if the first one is greater than the second one, or the second one is greater than the first one. There's also an equals method that we define, and we need this for other things like determining whether the items are distinct. And in this case, we're going to compare two quote objects to determine if they're equal using something called the pattern matching instance of operator, which came along in a Java release several years ago. And what we do here is we take the object O, and we say if the object O is an instance of quote Q, and Q now becomes the name of this if that succeeds, then we're going to check to see if the quote field equals Q quote field. And so that's a nice, clever way we can kind of make this really clean. It's a really clean and easy way to implement equals. And then the final method in quote is the hash code, which just computes the hash code for the quote using the object's hash method, which comes out of the box and works on strings. And we need this again for things like distinct based on how it's implemented. So there's one final class here that's part of the common portion that's relevant, and this is the ArrayUtils class. And this provides a bunch of static methods that can be used to convert various types of objects, Java objects, into their concrete types. And we need this because of the way that R2DBC handles custom queries. For reasons that somewhat escape me, R2DBC doesn't have a way of being able to convert elements in the database in a custom query from whatever the element is into its type. So you have to convert it from an object into a string and then into the type. And so we define a couple of methods here, one called obj2list, which basically takes an object that is actually an array and converts it into a list of elements of type class, if that's in fact the type that it's got. And then as part of that process, and as well as something we use in our implementation, we also have a helper method called object or obj2number. And this converts an object into a number subclass of type T. So a number subclass would be something like integer or double or long with a capital L, and so on and so forth. So you'll see when we get to a little bit further down in the code where we're going to actually do the custom SQL queries using R2DBC, the mechanisms to do that we're going to use this obj2number helper method in order to be able to convert the object that's stored in the database into its corresponding integer number. So that's the end of the walkthrough of the QuoteServices app case study common structure and functionality.